Hello everyone, now we are going to solve the questions based on the partial balancing. In this question, it is given that in a case of partial balancing of single cylinder reciprocating engine, what is the primary disturbing force along the line of stroke? We have studied this topic very carefully and very deeply. Okay, so you will be able to understand what would be the answer. Okay, there is no confusion that it is talking about the primary forces. First, primary forces and the forces along the line of stroke. So if there is a crank which is attached at a radial locations and this is a line of stroke like that, if I ask you to calculate, if I ask you to find out the component of the centrifugal force along this line of stroke, that would be considered as F primary. Okay, so F primary is nothing but the component of the centrifugal force along the line of stroke. Okay, this is known as the primary unbalanced force. So it would be considered as what? 1 minus c mr omega square cos theta. Why 1 minus c? Because we have studied in the primary balancing that we assume here the mass b, which is at a radius small b, and we know that bb is equal to cmr. C is the fraction of reciprocating masses to be balanced. Okay, so that's why his component would be in the direction, so that would be considered cmr omega square cos of theta. So that's why, and there is a mr omega square cos theta. So finally you will get 1 minus c along the line of stroke. You will get the value because c is less than 1 and greater than 0. That's why 1 minus c mr omega square cos theta. Okay, so this is the primary disturbing force along the line of stroke. Okay, so for this question, option B would be the correct answer. There is no confusing in the options because the options is very different. You have not seen in the derivations. If in the question the option is like that c mr omega square sin theta, so it may be a little bit confusing because it is a vertical component, so it can be the confusing options, but here the options are very different to each other, so it would be easy to find out the correct answer, that is 1 minus c mr omega square cos theta. Okay, so for this question, option B is the correct answer. So